In this section, we're going to talk about index numbers. And in general, an index number is used to compare measurements made at different times. And one of the most common index numbers, which we're going to talk about a lot in this section, is called the Consumer Price Index. And you'll see it abbreviated CPI. Now, the Consumer Price Index is an index number that is used widely in the United States that is based on price changes on a group of selected products, like gas prices or grocery prices. And we're going to use the idea of ratios in order to calculate these CPIs. When we look at the first example, we're given a chart that is related to gas prices. Okay, now it says in example A, suppose the cost of gasoline today is $3.77 per gallon. Using the 1980 price as the reference value, find the price index for gasoline today. So by finding the price index for today using 1980 as our comparison, you're basically trying to find the percentage of the 1980 price of what that is today. So you're going to take the present value and you're going to divide it by the reference value, and then you're going to multiply it by 100% to put it in percent form. And this will be our index price. This is going to be our comparison. So our present value, what we're trying to compare, is the 377. And what we're comparing it to is our reference value, which is the gas price in 1980. So if we look at 1980, it's $1.22. And we multiply that by 100 to put it in percent form. When we do that, we get 309.0. So this is our index number for the cost of gasoline today using 1980 as the reference. So if I made another line in this chart and I added 2020, I made another line in this chart using 1980 as the reference, that's this column here, I would put down my price index is 309.0. In part B, it says, suppose it costs $15 to fill your gas tank in 1980. How much did it cost to buy the same amount in 2010? So this is where we're making another kind of comparison. We're actually trying to determine one price using the price index based on another price at another period of time. So when we do this, what we're going to do is we're going to set up a ratio. We're going to do the index for 1980 over the index for 2010, and then we're going to set it equal to the price of a tank of gas in 1980 versus the price of a tank of gas in 2010. Notice, and this is very important, when I make my comparison, if I put the index for 1980 on top, the price for 1980 needs to also go on the top. If I put the index for 2010 on the bottom, the price for 2010 needs to go on the bottom. They need to line up so that it's consistent. Okay, now, if we go ahead and fill in the information based on the table and what's given to us in the problem, I'm going to set up an equation. In the first fraction on the left, I'm going to put the index for 1980 on the top. Now, if I come up here and I look at my table, 1980, the price index is 100. So I'm going to put 100 on the top for the price index for 1980. Then I'm going to do the index for 2010, which would be 232.8. I'm going to put that down here. Now we're going to do the second fraction, which is a comparison of our prices. Now, the price for 1980 is given to us in the problem, and that's $15. However, the question is asking us to find the amount of that it costs to fill up a tank of gas in 2010. That's what we're looking for, is the price in 2010. So I'm going to label it X because that's our unknown. You can label it whatever you want, but I'm going to label it X. So now we have an equation set up. We have some ratios. And when we set up an equation like this, we're going to use cross multiplication to figure out what X is. So I'm going to take 100 times X, and that's going to be equal to 232.8 times 15. So then to solve for X, I'm going to divide both sides by 100. So I'm going to get X is equal to whatever I get when I take 232.8 times 15 and then divide by 100. When I put that on the calculator, I'm going to get 3492. So what this tells us is, in 1980, if I had a tank of gas and I filled it up and it cost me $15 in 1980, in 2010, it would cost me approximately $34.92 to fill up that same tank of gas because of inflation, because the prices are going up. Okay, let's do part C now. Suppose it costs $21 to fill your gas tank in 2000. How much did it cost to buy the same amount of gas in 1960? Now, we can make sure that our answer makes sense, right? We're given $21 in 2000. We know the price has gone up over time. So when I find the answer for the same amount of gas in 1960, and it comes out to be more than $21, I know I made a mistake because it should be going down. In 2000 versus 1960, it should be less. So always make sure that your answer makes sense with the problem. That way you can catch some mistakes. Okay, but we're going to do this the same way. I'm going to set up a ratio. We're going to do the index for 2000 over the index of 1960, and then we're going to do the price. Now, because I put 2000 on the top on the left, I have to put 2000 on the top on the right. It doesn't matter if I put index of 1960 over index of 2000, but what does matter is you keep it consistent when you make your other fraction. So because I put 1960 on the bottom on the left, I'm going to do price of 1960 on the bottom on the right. Okay, so now we're going to fill in the information. So I have to find the index in 2000, so I'm going to scroll up. And 2000, if I look, it's 127.9. In 1960, if I scroll up, let's see, in 1960 it was 25.4. Okay, now the price in 2000 was given to us as 21. So what we're looking for is the price in 1960, so I'm going to call that X. And then I'm going to use my cross multiplication. So I'm going to do 127.9 times X. And that's going to be equal to 25.4 times 21. And then I have to divide both sides by 127.9 to solve for x. So to get x, these go away. To figure out what x is, I'm going to take 25.4 times 21, and then I'm going to divide by 127.9. When I do that, I'm going to get $4.17. So that makes sense. We know it should have been lower because our prices are going up over time. So our price should be lower in 1960 versus 2000. So it definitely makes sense. So if I bought gas in year 2000 and it cost me $21, if I bought that same amount of gas in 1960, it would cost me $4.17. Okay, now we're going to talk specifically about the Consumer Price Index. Now, as I said before, the Consumer Price Index is like an average of prices based on a whole bunch of services and products that people purchase. Now, if you look up the CPI online, they have monthly CPI values. Like as it changes every month, they update it online. The chart that's here in front of us is based on an entire year. These are the annual CPIs. So we're going to do these problems just like we did before. We're going to use ratios. So keep in mind that the CPI is a type of index number, and so we're just going to follow through just like we did in the previous examples. Now, it says in this example, suppose that you needed $30,000 to maintain a particular standard of living in 2000. We want to figure out if we want to maintain that standard of living in 2012, how much money are we going to need? As you know, prices go up every year for inflation. So how much are we going to need in 2012? And this is what we're going to use the CPI for. Set up a ratio. So we're going to do CPI for 2000 over CPI for 2012. And we're going to set up our standard of living in 2000 would be 30,000. And what we're looking for is the standard of living in 2012. So that's going to be our unknown, what we're looking for. So I'm going to use cross multiplication to solve for x. So I'm going to do the CPI in 2000 times x. And that's going to be equal to the CPI in 2012 times 30,000. When you look up on the chart, the CPI in 2000 is 172.2, and the CPI in 2012 is 229.6. Now, this isn't on this page. You'd have to scroll down a little bit. So when you're looking at the worksheet and you're filling out the notes, keep in mind you have to scroll down a little bit to find that CPI down here for 2000. Here's 2000. Let me circle it here. Here's 2000 and here 2012. Okay, so we found the CPI for 2000 and the CPI for 2012, and that's going to be equal to 30,000 over x. So we're going to cross multiply, and we're going to take 30,000 times 229.6, and that's going to be equal to 172.2 times x. So to find x, we're going to divide both sides by 172.2. So x is going to be 30,000 times 229.6 divided by 172.2. And when you do that, you're going to get $40,000. So that means in 2012, if you maintain that same standard of living as you did in year 2000, you're going to need $10,000 more. You're going to need $40,000 rather than $30,000. Now, when we want to find the rate of inflation, that's basically the relative change from one year to the next in terms of the CPI. So if we want to find the inflation rate from 1978 to 1979, that's just finding the relative change of the CPI. So remember, when we talked about relative change in a previous lesson, the relative change or percent change would be if you take the new value minus the old value, you divide by the old value, and then you multiply by 100 to put it in percent form. So in terms of 1978 to 1979, this would be the old value, that would be 1978, and then the new value would be the CPI in 1979. So we're going to take the CPI of 1979. If you look up in the chart, you'll see that that's 72.6. We're going to subtract the old value, which is the CPI of 1978, which is 65.2. And then I'm going to divide by 65.2 and multiply by 100 to put it in percent form. And what you'll find is the rate of inflation from 1978 to 1979 is 11.3%. That means, on average, the goods, or the price of the goods, has increased 11.3% from 1978 to 1979. Okay, in the next example, it says, in 1987, the average salary for a Major League Baseball player was $412,000. Then in 2012, it was $3,440,000. We're going to compare the two salaries in 2012 versus what the inflation amount should be. And we're going to then answer the question, how does the rise in baseball salaries compare to the overall rise in prices with inflation? The actual salary in 2012 is $3,440,000. What we're going to do is we're going to start in 1987, and we're going to use the salary of $412,000, and we're going to use inflation to see how much, based on inflation, the salary should be in 2012 and compare it to the actual salary. So in 1987, the CPI was 113.6. Okay, the CPI in 2012, based on the chart, is 229.6. So we're going to set up a ratio. We're going to do the CPI of 1987, which is 113.6, over the CPI in 2012, which is 229.6. And then we're going to compare that to the salary in 1987, which is $412,000. And using the rate of inflation, we are going to compare what inflation says the salary should be in 2012 versus what it actually is. So if I solve this for x, I'm going to cross multiply. I'm going to take 229.6 and multiply by 412,000. And that's going to be equal to 113.6 times x. And then to find x, we're going to divide both sides by 113.6. So on my calculator, I'm going to do 229.6 times 412,000, and then I'm going to take that answer and divide by 113.6, and I'm going to get approximately $833,000. I should do the little squiggle line here because this is an approximation. That doesn't look good. Let me fix it. approximately $833,000. So what this is saying is if we use the rate of inflation and we start at 1987, the salary based on the rate of inflation in 2012 of these baseball players should be $833,000. However, if you look at what they're actually making, it's over $3 million. So if you look, the baseball salaries have far outpaced the rate of the inflation. So we can say that the average baseball salaries is more than quadrupled than what it should be based on inflation. So they're making a killing, is basically what this is saying. This is what the rate of inflation is saying they should make in 2012 versus what they are actually making. Okay, last example. It says, according to the computer performance test, a Macintosh computer that cost $1,000 in 2012 had computing power greater than of a supercomputer that sold for $30 million in 1985. If computer prices had risen with inflation, how much would the 1985 supercomputer have cost in 2012? And what does this tell us about the cost of computers? So, if we look at the CPI in 2012, again, we looked that up on the chart. That's going to be 229.6. And then if we look at the CPI in 1985, that's going to be, when we look that up on the chart, 107.6. So in 1985, a computer sold for $30 million, these supercomputers. We want to see, based on the rate of inflation, what a computer would be in 2012. We know that we can go online to the Apple Store and purchase a MacBook Air for maybe approximately $1,500 to $2,000. But based on the rate of inflation, that's going to tell us it's a huge difference. Okay, so we're going to set up a ratio. We're going to say the CPI in 2012, that's 229.6, and over the CPI in 1985, which is 107.6, that's equal to the price of a supercomputer in 1985, which is $30 million, over the cost of a supercomputer in 2012, which is what we're looking for. So if I cross multiply, I take 229.6 times x, and that's going to give me 30 million times 107.6. And then I have to divide both sides by 229.6. What that's going to give me, again, let me fix this so that it's an approximation. That's going to give me approximately $64 million. So if computer prices went up with inflation, the computing power of a 1985 supercomputer would have cost $64 million in 2012. But now we know that if we go into an Apple store or we buy a Dell online, we can get a laptop for $2,000 or less. So this really didn't rise with the rate of inflation. The cost of computers have really went down with time. So you can see that not all products rise and fall exactly with inflation. These values are just estimates.